Hello and welcome to BioRules video lessons. Today we are going to be talking about hormones, specifically about plant hormones. But what's a hormone? Hormones are chemicals produced by a body, produced by the organism itself, that has an influence in the organism growth, development, or basically it signals the organism or any part of that organism to do something. In humans, it's signals for muscles to develop, for us to produce sweat or urine, or for us to grow or to have a bigger metabolism. So in plants, they also have their own hormones. In the plants, they are going to be called phytohormones. Why? Because phyto reminds us of plants. So it's the name for plants. Plants, hormone, phytohormones. And they are going to be affecting the plants in the same way that hormones affect animals, signaling the organism to be doing something. Okay? Just to set you an example, here you have a plant, and voila, we have hormones. And the hormones going all around will signal to this leaf to, hey, it's time to go. Autumn has arrived. Now the leaves are falling. You should fall as well. Okay? One very important hormone that we're going to be studying, because it has a major effect. No, it has actually not only a major effect, but has many, many important effects, is auxin. Actually, I would say that auxin is one of the most important hormones that we're going to be studying. If you are in doubt, guess auxin. It has many different roles. One of them is that this hormone is going to be promoting growth. It's going to be promoting stem and roots growth in a plant. So here you have a graph now plotting the concentration of auxin in the x-axis, and we are plotting the stimulation for the stem in green or the roots in brown to be growing. And what we can see is that in small concentrations over here, nothing happens to the auxin, but the root is stimulated. Yay, very good. But on higher concentrations, what we would consider normal concentrations over there, the stem is stimulated to grow and the root is inhibited from growing. This here will be very, very, very important for us. So the normal concentration will be important for us on the effect of auxin, because usually the plants are going to be having auxin in a normal concentration or not at all. Okay, so let's see this effect on growing of the auxin. Auxin is produced in the tip of the stem. We call it the apical meristem. So auxin is produced in the very growing tip of a plant. Okay, and this auxin that's produced over there don't stay there. It spreads down, it diffuses away from the apex of the plant and goes getting down and down and down. So the auxin go ahead and they distribute, and now here we have the auxin place that's produced in the apex of the little plants. So what will happen if you have auxin be distributed all over the plant? What you have is that at the normal concentrations over there, auxin is going to be forcing the stem to elongate. So there we have normal concentration and the stem will elongate to grow. But at also the normal concentration for the roots that we have over here, it's going to be inhibiting the root from growing much. So if auxin manages to get to the roots, it's going to be holding back the roots and not make it grow much. Okay, so why is this important? Because if we look at the cellular level, this is what we're going to be having. Okay, without auxin, so if you have a very low concentration of auxin, we are going to have the roots being stimulated and the stem not stimulated to grow. But where we do have auxin, we are going to have the stem cells elongating and the root cells now being held back behind. So this will have a major effect. So basically, the tip of the plant controls the growth of the plant, but it's going to be further than that. It will be more than that. We have no other effects. So one of them is called tropism. Okay? Tropism is the directional growth of the plant, which basically makes us feel like the plant is moving in one direction. Here we have plants growing toward the light. And here you have the plant growing against gravity, in that direction. So plants, they know where to grow. They grow toward light. Light's good for them. They grow toward the light. Yeah, that's amazing. Also, if they fall down, they know that they have to grow up, because usually, up is where, the top of the trees and the leaves are going to be over there. That's where the sun is going to be, up. Okay, so let's talk about phototropism first. Okay, it's one kind of tropism. Here we have auxin produced in the apical meristem and distributed in the end almost evenly through all over the plant. So that's how auxin gets distributed in a plant. However, auxin is a hormone that's sensitive to light. Where sunlight hits auxin, it gets degraded, it gets broken down. So if it's broken down in the lighty side, it accumulates in the shaded side of the plant. So now we have a different concentration of hormones depending on the side that the plant is receiving sunlight. At the cellular level, this is what's going to be happening. We are going to be happening to have on the left side with auxin, on the right side without auxin. So basically I'm representing here the levels of auxin. And what's going to be happening is that on the stem, the green part over there, as we saw before, auxin promotes elongation. So the cells on the green side, they are going to be growing where you have auxin, on the shaded area. But it's not going to be growing in the lighty area. If one side grows, the other side doesn't grow, the plant ends up anchored in one side and it tends to bend in the direction that they are not growing. So in this case here, the stem is going to be bending in the direction of the light. The opposite happens to the roots. Not so strongly, because in the roots the effect is holding the growth, but auxin over here holds the growth, so the plant is going to be anchored over there. So the side that is in the light grows, elongates itself, and anchored over there, it ends up bending away from the light. So as a result, the tip of the stem bends itself in the direction of the light, the roots bend themselves away from light. Roots try to escape from light, the stem try to grow toward the light. So auxin promotes stem cell elongation and make them to grow in that direction, and inhibits the root elongation. So this is what makes us to have this phototropism. The directional growth actually is because of the presence of auxin in the dark side. If you have auxin accumulated here in the dark side, it will force the side to grow and then it bends in that way. But if you have auxin in the roots over here, it doesn't grow much, so this side will grow and then it will bend in that direction. This is phototropism. Okay? Now, what about gravitropism or geotropism? That's different. The plant's not going to be growing toward light. This here they're growing toward light. What will happen in geotropism is that the plant is going to be growing in relation to gravity or in relation to the ground, to gel, to earth. Auxin spreads over the plant that is laying down over there. However, gravity acts on auxin. It pushes auxin down. Yes, it's on molecular scale, this force is not going to be very strong there, but it tends to accumulate auxin in the bottom. And now you already know. If it accumulates auxin in the stem cells are going to be elongated, so this is going to be growing in that direction. So they grow against gravity. And on the roots, they are going to be doing the opposite. The part that doesn't have auxin is going to be growing. The part of the root that accumulated auxin is going to be inhibited from growing, so the plant, the roots, will tend up to grow away from no, actually not away, in the direction of the gravity, so it grows toward the ground, trying to get down over there. So this is the effect of geotropism and gravitropism. Okay, so auxin promotes the stem elongation there in the stems, and it inhibits root cells elongation. That's how it works. It's the same mechanism in both phototropism and geotropism. This is how plants find the light. That's how plants find the way up. They don't see. They actually have hormones that are placed depending on light, depending on gravity, and they just grow in response to that hormone. Okay? So, now we have a series of questions in our questionnaire. So if you read the QR code with your camera in your cell phone, it will open this website, or you can use the link to open this website in your computer, and you're going to be having a few questions to answer. I hope you have fun.